Hi guys, today we're going to talk about the reciprocal function. The reciprocal function is written as f of x equals 1 over x, as you can see right here. And it is a member of the rational function family. So rational numbers, remember rational says the word ratio. It's the root word is ratio. And a ratio is a comparison of two numbers. You can just think of fraction. That's what a ratio is. So we have 1 over x. Now that creates a graph that looks like what you're seeing here on your screen. So if I plug in 0 for x, the function is undefined because we cannot divide by 0. Therefore, we have nothing happening here. There is a vertical asymptote at 0, x equals 0 here, and at y equals 0. Now if I plug in 1, 1 over 1 is 1. So right here. If I plug in any values between 0 and 1, then I will get whatever that value is. So if I plug in 1/2, well, 1 divided by 1/2, that's the same as 1 times 2, which would be 2. So at 1/2, I should be up at 2. So you could plug in points and determine, like make your XY table and determine what the shape of the graph looks like. This particular shape right here for the reciprocal function is called a hyperbola. Okay, so this is a hyperbola, and it's very important that you know it has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And because there are no values where those asymptotes exist, it is affecting the domain and the range. Both of the asymptotes affect the domain and the range. So let's talk more about the domain. The domain, remember, are your x values. So we're looking all the way to negative infinity on our x-axis and then going all the way across to positive infinity. Now, when we look at all of those values, because there is a gap right here, then when the value x equals 0, you have nothing on your graph to show for it. There is no point on your graph. So therefore, you have to stop. You have to jump to the other side of the graph and then continue making the other curve. So for the domain values, you can have all of the x values except 0. So x cannot equal 0. That's an equal sign with a slash through it. So x cannot equal 0. It is okay if you just write it that way. You don't have to tell me all of the values unless you want to. You don't have to say from negative infinity to 0, parentheses, union 0 with the parentheses to infinity. You don't have to say that unless you just really want to. Okay, the range. The range is affected by the horizontal asymptote here. Okay, again, if I come from the negative y values, you can see that the graph is using all of those negative y values, but when I get to 0, then I can't use 0 because there's a break in the graph. So we say the y cannot equal 0. Okay, so that's the domain and the range. Now in the next slide, we're going to talk about transformations. And just like with your logarithmic and exponential functions, depending on the asymptote, if I had a vertical asymptote and I shifted left or right, that's when the asymptote would move. If you have a horizontal asymptote, when you shift up or down, that would cause that asymptote to move. So remember those things. Okay, so the transformations here, again, A, that's going to control your vertical stretches and compressions. I'm going to put vert for vertical stretches and compressions. And of course, that changes that changes the shape of the graph. It makes it like skinnier or fatter. So that just changes how the shape looks. Okay, if the A value is negative, it's going to cause it to reflect. If A is negative, less than 0, it'll be a reflection. I'm just going to say reflect. If A is less than 0, so if we have negative A, it's going to cause a reflection. Now I'm going to go back to this slide here for just a second. If we were to reflect, imagine this reflecting both parts here, reflecting over the x-axis. Well, that would turn into something that looks similar. Oh, I know that's horrible, but it would look similar to this if I reflected over the x-axis. Okay, if I reflected over the y-axis, it would be the same thing. Okay, I'm doing a horrible job of doing that. Hopefully you can see that. If not, ask me to show it to you in class, and that way I can explain it better. But no matter what, we're just going to say if the A is negative, it just reflects. We're not going to say over which axis because it would be either one. Okay, the H value. Look, it's with the X. The H value always shifts you left or right. Shifts. And of course, the K value shifts you up or down. Now, because the parent function for a reciprocal function, the parent function has both a vertical and a horizontal asymptote, you may end up moving the shifting left or right and only moving the vertical asymptote. Or you may keep the vertical asymptote in place and only shift up or down. Or you could move both of them, okay, at the same time, and so therefore your domain and range is going to change, and your vertical and horizontal asymptote could change too. So what we're going to do is we're going to look at this one. All right. So just identifying the transformations, the 2 here, that's been vertically stretched by 2. Stretch. Okay, and we shifted to the left 1. And then we went up 2. Okay, so notice, if we had the original parent function, we would have a vertical asymptote on the y-axis and then one on the x-axis. But because we've moved it up 2, the horizontal asymptote is now at y equals 2. So you have a horizontal asymptote at y equals 2. This is the format. If I'm asking you to tell me where the horizontal asymptote is, you cannot just say 2. You have to give me the equation of the line so that I know what you're talking about, okay? And don't just say horizontal asymptote equals 2. Horizontal asymptote, this is a symbol for at, y equals 2. This is appropriate. This is the way that I will accept it. Then we shifted left 1. So the vertical asymptote that would have been on the y-axis has moved to the left 1. So now it's at -1 vertically. So we will say the vertical asymptote is at x equals -1. All right. The domain and range. If we look at our graph starts negative x values. We could go all the way to negative infinity based on this arrow here. Curve around, And we could go as close as possible up to -1, but we're never going to reach because of that asymptote there. So then once we pass over -1, we'd start back up here and keep continuing on forever and ever to positive infinity. So the domain x cannot equal -1. Everything else is okay, but x cannot equal -1. The range, again, it is controlled by the horizontal asymptote, because if we look at our y values, the y values will go from -infinity all the way up, 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 but once we get really, really close to the 2, we have to jump back up and come up over here, and then go up, up, up forever and ever. So at 2 is where we have a problem, so y can't equal 2. Okay, so notice the vertical asymptote controls the domain, and the horizontal asymptote controls the range. One more? All right. So there's a negative out front here, so that negative tells you, I'm going to highlight here, that negative tells you that there has been a reflection. All right. Because there's a 1 up here, and my parent graph had a 1, that means there's no stretches or compressions being done based on that number there. We did shift to the left 1, and then we also shifted down 2. So because of the shift to the left 1, our vertical asymptote has changed. So we have a vertical asymptote. Oh, goodness. At x equals -1. And that controls the domain, so our domain means we can't have any x values at -1, so x can't equal -1. And then for our horizontal asymptote, the horizontal asymptote has moved, and it is now at y equals -2, because it moved down 2, which means the range is affected. And we can use all values except -2, so y cannot equal -2. So these are all the things that you need to know about for reciprocal functions, and we will continue talking about this in class. Ask me if you have any questions.